Welcome to aminacademy.com. In physics, regarding thermodynamics, let us discuss about cyclic process. The process in which the initial and final states are the same as known as a cyclic process. It is a sequence of processes that leaves the system in the same state in which it started. Hence, the work done by the system in a cyclic transformation is equal to the heat absorbed by the system. Here, look at here, the process start 1 to 2 and return back from 2 to 1. So, it is a cyclic process. When a system undergoes a cyclic process, its initial and final internal energies are equal. Hence, the internal energy change in any cyclic process is zero. Applying the first law of thermodynamics to a cyclic process, we get delta E, that is delta U, you can write, internal energy equal Q plus W if delta U equal to 0, then we can say W equal to Q. W work is heat energy added or heat work is equal to heat energy added. Here regarding the work nature, it may be negative or positive. Hence, the work done by the system in a cyclic transformation is equal to the heat absorbed by the system. The network involved in a cyclic process is the area enclosed in a PV diagram. If the cycle goes clockwise, the system does work. If the cycle goes anti-clockwise, then the work is done on the system of every cycle. An example of such a system is a refrigerator or air conditioner. The Carnot engine is the best example of a cyclic process. Now we'll discuss about heat engines. A heat engine is a device by which a system is made to undergo a cyclic process that results in the conservation of heat to work. Some notes here. Heat engines consist of a working substance, the system. For example, steam in a steam engine is the working substance. The working substance goes through a cyclic of several processes. In some processes, it absorbs heat from a reservoir at a higher temperature. In some processes, the working substance releases some amount of heat to an external reservoir at a lower temperature. The work done by the system in a cycle is transformed to the environment through some arrangements. For example, the working substance may be in a cylinder with a moving piston that transfers mechanical energy to the wheels of the vehicle. The schematic representation of a heat engine is represented as follows here. Look at here. Here hot reservoir, here cold reservoir. So in cold reservoir, heat is added, work is done on that, and go to hot reservoir. The heat, released heat goes to the hot reservoir. That means work is done by the engine. The cycle is repeated to get the useful work done for some purposes. A refrigerator is a reverse of the heat engine. Here, the working substance extracts some amount of heat from the cold reservoir at some temperature T1. External work W is done on it and heat Q is released to the hot reservoir at a temperature T2. The schematic representation of a refrigerator is given below. Here, this is a turbine, gas turbine or steam turbine. Schematic arrangement is there. In a cyclic process, the system starts and returns to the same thermodynamic state. The next network involved is the enclosed area on PV diagram. If the cycle goes clockwise, the system does work. The cyclic process is the underlying principle for an engine. If the cycle goes counterclockwise, work is done on the system every cycle. An example of such system is refrigerator or air conditioner. Some example of cyclic process: expansion at constant temperature T1, removal of heat at constant volume V2, compression at constant temperature T2, and addition of heat at constant volume. These are some cycles example. A thermodynamic cycle consists of linked sequence of a thermodynamic process that involves transfer of heat and work into and out of the system, while varying pressure, temperature, and other state variables within the system, and that eventually returns the system to its initial state. Here are some examples for thermodynamic cycle. We have done. Please subscribe our YouTube channel.